Great, hello. OpenBuildings is a product line that we have two main products. OpenBuildings Designer, which is a scalable BIM application for any type of building. And we also have OpenBuildings Station Designer that specializes on above ground and below ground rail stations. OpenBuildings is a multiple discipline BIM application that has tools for architecture, structural, mechanical, electrical, facilities that includes spaces and assets, as well as its unique posturing that it is a BIM application that runs on top of a CAD engine. So we have DGN built in. You don't have to translate between BIM and CAD as you work. We have built-in clash detection, so you don't have to go into another program. We have built-in rendering. We have generative design and conceptual modeling tools all built in. So first we'll be looking at our OpenBuildings Energy Simulator, which is a product that installs with OpenBuildings Designer and uses the same license. It is based on the emerging global standard of Energy Plus, so it allows designers to fully contemplate and assess design decisions early on, so you could be using this tool on existing or new buildings. So we're going to start off by looking at the conceptual modeling tools that are in OpenBuildings for a building, and then move it into the energy tools before you start doing more detailed modeling. So we'll be looking at a OpenBuildings model in context of a 3D scalable mesh model with our massing model. So in this video, you'll see that we are in OpenBuildings. We have our 3D scalable mesh. So that is a 3D model from photographs using context capture, either with drones or handheld devices. That purplish solid is our massing that we've actually flooded each floor for the square footage of the floor plate. So when I push and pull on those different faces of the building, the square footage will automatically update. So if I go ahead and grab the face of the one building, the side of the front of the building, and pull it out, you'll see on the schedule on the right the square footage of all those floor plates automatically updating. So I could be grabbing a face, an edge, or vertice of our solids. If I grab up with the mechanical and be pulling it up, I could actually snap over to that other building off onto the left to match that same height, because it is the snappable, scalable 3D model from photographs. And then I can go in and do other cut and Boolean tools, or I could fillet the corner of the building, and you'll see that I can, when I put the curve in, the floor plates automatically update, and that square footage is automatically calculated. So you just have some intelligent tools as you're in modeling your massing model. We also have tools for solar analysis that are built in. So we'll see that we can go on and turn on our solar analysis tools. We also have tools to do solar study animations, 3D volumetric or outline shadows, and output to solar exposure catalog, which we'll be showing here. So we've isolated the building. We can go into the solar calculator. We can go in and give it an increment. We can import weather conditions, durations, the start and end time, and then we can output the results to a CSV file or to a new model in this model file, or we can go to an external file as well if we want to be doing different comparisons of different design schemes. So we're outputting this to another file for our review, and we'll be comparing different scenarios. So we output that, and once it appears, you'll see in OpenBuildings that we have display styles that will show the exposure. So on that curved wall that I had, that's on the south side of the building, it's in red because it has more hours of solar exposure on it. And that's just a design style that's built in that automatically puts that chart in there for you. And then since that our site model is a scalable mesh, we can do the entire site. And in this slide, you'll see that on the left is the solar exposure. So the most sun is in red, the most shadow is in blue. And then on the right, I'm doing a shadow study, which is the reverse. So the most of the shadow is in red and most sun is in blue. So you have those two options built in as well. And now we're going to go in and go into our energy simulation to be bringing in our model. So when we start OpenBuildings Energy Simulator, we have two different modes. We have the conceptual modeling mode, which I'll be showing you now, or we have the standard, which is going from a full BIM model. But what we're going to be doing is taking that massing model that we started, that we have no doors, walls, or windows or anything yet, just a massing, and start applying some scenarios about energy on that model. And so within the application, conceptual modeling mode, we have 4 tabs: project location, model creation, thermal properties, and simulation. So for project location, you go in and give it the project a name, the engineer, the country, state, weather profile, and then you can define where is north. So you don't physically have to be rotating the building when you're doing different simulations. And then at the top, there's also a geometry tab. So we can trace a 2D CAD file into 3D. We have solid modeling tools to actually be doing solid modeling in the application. But what I'm going to do is reference in that massing model that we used on our context capture site before. And so fit it in each window. So there's the massing model. I could have opened it up. It is a DGN file, but I'm going to merge it into a new file because we're going to go in and be able to slice and dice and make some other changes to the model automatically. So one of the things we could do is go in and be changing the floors. So we can go in, define floor heights and be changing that, the number of stories and what the floor to floor. So we could be doing different simulations on what would happen with energy analysis if I change that. We can also go in and say, what percentage of glazing do we want per floor? So I'm just going with 40%. And then you click on the Create Building button, and it's going to go through and take that solid, and it's going to then start cutting up by floor. And then you'll see it'll start putting the glazing in by floor as well. And there are also options for external shading for fins or sunscreens, overhang projection percentage of the window height, and then we also can do skylights and things like that. So you're seeing the windows are starting to be placing in here, and then we can also do a auto zoning feature, which basically can go in and give you a core. So in this case, I'm saying, okay, I want my office area to be 30 feet deep from the exterior of the building, and in the upper right view, you can see how it's just moved back 30 feet, or you could be putting in an exact value of what that core would be. Then we'll be looking at the thermal properties and then run a simulation. So in the conceptual mode, the third tab is the thermal properties. And we'll go in and select ASHRAE 2010 from the pull down along with the building and room type. And then we have our material manager that has default settings for construction assemblies and U values for walls, floors, ceilings, and roofs. And these can be modified later and then updated on the model. So we can go in and make some quick, take some default settings of the different types of constructions, the U values, see from a pick list. And then I can go down and make some quick settings about the internal conditions of the winter and summer, infiltration values, about the heat gains, about the lighting, and then what the occupancy would be down at the bottom when we're entering those values in as well. So I'll make it the density of 200 square feet per person, and then we'll go in and enter that in and apply it. And then the fourth tab after this runs here is going to be the simulation. And once we've completed that, we click on that fourth tab and we go in and give it a name and a description. This is where we're going to be running different scenarios. So in the name and description, you might want to go in and say, okay, this is a 40% glazing with the north at 270 degrees. We can go in and give it in the description there. We can do a full year. we can go in and choose what the HVAC settings is. So the first one, I'm selecting a packaged VAV air-cooled system with electric heat. And then I'll select the airflow type to 15 cubic feet per person and then do apply. After that, and then once that runs, down at the bottom will be your results. So the concept is you go in, you make these settings, and then you can go back and be comparing them back and forth. So after this runs down at the bottom, we'll see it, and we can just open the simulation and review the results. And if I go and click on Review Results, Conceptual Report, we'll get this report. It can go to CSV, or here it's going to a PDF. So we're seeing that the building rating is good for the actual energy consumption. We're seeing the report on the monthly outdoor temperature report. There's an energy efficiency pie chart for the heating and cooling fans and interior equipment and lighting. Then there's the monthly fuel report, the monthly cooling gain, monthly heating loss, monthly solar gain, all that information just based on that solid model that we had, applying different systems of the building and then different materials on it as well. So then we can go back and we can be doing another simulation. So in this one, we want to go in and change the mechanical system. So we're keeping the glazing the same, we're keeping the orientation the same, but we're just switching it out from electric to a gas system, just as a comparison to show that you can go in and be doing that comparison or that change, and then select from that pull down, and then apply. And then when it runs, now at the bottom, you'll see two reports. So what we're able to do is take that gas and electric, select them both, and then select on the compare button. So when we open up our report, we'll be seeing both of them side by side when we maximize it. And then you're seeing those results between the two. So it's a quick way to be doing these different comparisons early on in the design before you've drawn very much. You're able to get the energy impact on these different material changes, orientations, floor to floor, based on the systems that you're using, anything like that. And we could also look at reports of, all right, take that same model, and without modeling any glazing, what would it look like, or the report look like, if there's 50% glazing per floor versus 44%? Or what would happen if we rotate the building? Maybe you're doing a test fit. You don't know what site you're going to select yet, but you could start rotating the building to see which has the best energy performance very early on in the project. So the other method is the standard method. As I mentioned before, we chose conceptual. The standard method of energy simulation, OpenBuildings Energy Simulator, is going from a BIM model to energy simulator. That's when you have walls, doors, windows, and spaces defined, so we can be bringing that from OpenBuildings and even from other BIM applications as well. So now I'll hand it back to Joel to go through our bidirectional structural analysis.
Thank you very much, Mark. Now we're going to talk about, as Mark said, bidirectional structural analysis.